Hello and welcome to TelecomandoRC. So again, we're talking about Differentials 101. So this is part of the series. If you have not watched the other videos, please do so. Now in this one, I'm going to be talking about ball differentials versus gear differentials. And I'm going to go over the basics, and hopefully this helps you decide what is best for your applications. Now there are many vehicles that come with a ball bearing differential, this Schumacher style. That's the way I've known it, as a Schumacher style differential, but I guess ball differential is the most common. There are a lot of touring cars, also off-road cars, buggies for example, B61, B62, those came with this style differential. Sticking with Team Associated, for example, we have their short course trucks, SE 6.1, SE 6.2. So both of those trucks come with this differential. Well, 6.2 replace 6.1. And the way it goes is, pretend this is the gear. I didn't finish off the teeth. But the gear is part of the housing, so that goes on the outside. So we're just going to ignore the housing. What you find is two metal plates. And these metal plates, these are these discs. And there's a hole for the shaft to go through. And there's also another bit in between. So part of that gear, there's a race that's on there. That's where it's a flat surface with little holes. That's where the ball bearings actually fit. This would be the actual metallic part. And these ball bearings are housed within those holes in the gear. Now, if we ignore the entire housing, that race, we would have something like this, a disc with a lot of little ball bearings just around, orbiting around. So you have this planetary system. Now, if we were to look at the side view, the gear, you would have the gear here on the outside, the teeth would go this way. This surface area is exposed, this surface area is exposed, and then everything here is sealed inside. And then you would have a shaft that goes right through the middle. So imagine that hole is in here. And the little ball bearings are lined like this. Now, the race would go right here in between, which I did not draw, just to make this drawing simpler. So again, the gear, you could almost imagine it as a T. If I were to do a cutout, it would look like a T. But this is what it looks like. Now, you do need lubricant on the surface of this metal plate, and that's for there to be lubricity for these balls to race about the disc. If not, you're going to run into trouble, so I'm going to go into that. Now, these two plates come in contact with these little balls. So when the differential effect takes place, what happens is this disc will, say, rotate. Imagine this disc is rotating toward the screen. This one would rotate out of the screen, which means that these balls would spin around, allowing for that differential to take place. That's the way this works. So if you imagine this ball spinning left, that means that this disc is going to spin up into the screen, and as this is still spinning left, this disc is going to spin down out of the screen relative to the top. So this will come out, that will go in, this will come out and then go into the screen. That's how the differential effect takes place. Now, if the traction is in equilibrium on both tires, then this will all spin as one unit and there will be no differential effect between the two. Now, we're just going to pretend it's constant, so the motion is constant for the purposes of this. The balls are just rolling on top of the surface. That's it. And there's a lubricant, a coat of some type of lubricant, differential grease, right here between the two to allow these to roll. Now, if you start losing too much traction or you want to create less of a differential effect, you can always tighten this. Because this will simply have a spring on one side with a nut, and then you just tighten the nut. It's accessible from the outside. You just have to remove the drive shaft, and then you can go in there with your driver, tighten it, and that's pretty much it. Now, the downside to that is the following. If you over tighten, you may create some flat spots on the ball bearings, and then the ball bearings will start dragging, which means there's going to be more wear to these plates. Something else that you can have over time is, let's just say these balls are rolling the way they are, they will begin to groove up the surface of this disc. So this disc, depending on how often you drive it, it does have a life. You will have to replace the ball bearings inside as well as those two plates. Not to mention the spring. Eventually you're going to want to replace that as well. Long story short, everything but the external gear, unless you damage that too. But there is a life to this. And you do have to, this requires, in my opinion, requires more maintenance. So every time that you go out, have a long race, you really do want to check it. The other thing too is when you're setting this, you really don't want to drive the nut all the way in and then back it out, because that will apply additional pressure here, and you may get some flat spots prematurely. So you generally want to check it in a different way, and that's you bring in, tighten it just a little, say 1/8 of a turn, and then you hold the two tires, and then you throttle the car, sit on the ground, and then see if there's a what the differential is doing. That would be for another video. But that's sort of the function of it. So there are some downsides. Now there are some upsides as well, and that has to do with the way this type of differential drives. Now this differential is highly desirable for tracks where there's low traction or they're very bumpy. And the reason why is because the differential is very responsive. It reacts very, very quickly as a differential. So let's just say these are bumps, spots, holes, it doesn't matter. The vehicle is going to run, say this is a two-wheel drive, and it's going to hit or fall into one of these. So one of the tires, whichever one loses traction, that one's going to unload, which means because that one's unloading really fast and the differential is very fast in acting, the other tire is going to keep straight. So the car, it's easier to track a car straight, especially at speeds, with a ball differential for this reason. If you're taking a turn, for example, say it's loose dirt, this is the inside rear. This will start unloading, which means that the car is going to continue tracking on the path of the curve. As soon as you start, notice it's the inside rear tire. As soon as you change direction, your weight's going to shift, and now it's going to be the right side tire, which is now the new inside tire, that's going to start unloading. The advantage of this is the following. For example, if you had a locked differential, what would happen is this tire would lose traction and then this one would pull the car. This one wants to go straight. Your tires are turning to the left, which means that relative to the left turning tires, this wants to go to the right. So if we were to draw a straight line here, right, this one would be right of that straight line. And what ultimately ends up doing, for example, with a locked differential or a differential with a lot of resistance, is you will spin out. With a ball differential, it's a lot easier to control because that wheel is unloading. That's the reason why. So it doesn't give the outer tire, the one with more traction, enough power to spin out the vehicle. Therefore, this one will unload enough force, enough energy to maintain the traction that it needs to continue the turn. So on loose dirt, ball differentials are very, very effective. Bumpy surfaces, they're very effective for that reason. They tend to track straight, again, because it unloads that extra energy, and the tire with more traction doesn't just take off and want to run away, for example, in a different direction. So let's just say tire comes off the ground, same thing would happen. This one would unload. Now these are the outer, that's the inner. This one would simply unload, and that tire would not push on the car, which is generally when you spin out. When you spin out, what's happening is that tire with traction is pushing on the car from the rear, and when you push from the rear, you're going to spin out from this perspective. Now, a gear differential works different. It works with gears. Now, the most common form of differential that I've seen is a conical differential. So imagine these are cone gears, so you would have the teeth here going in here, and these would all be in contact. Now, this would be within a case, and in that housing, you would have a fluid. Sometimes you only have grease, and that's fine. The grease is just to create lubricant. If you have a differential with grease, here's a little recommendation. Do not use black grease. Use red grease. Red grease is a little stickier. So if you have a differential that is not sealed, you do not want to put fluid in there because, let's say, I don't know, 40 weight differential fluid, 40,000, I apologize, would leak out. 100,000 would leak out, but then if you went to say 1 million, it may not leak out, but it's too much because say it's the rear differential. You don't want something that heavy on loose or bumpy surfaces. You're going to be spinning out. What you can do is you can use red grease. Red grease is very, very sticky, naturally sticky, incredibly sticky. That's something you can use. Now, if it's a sealed differential, you can use a variety of different weights of silicone oil. And you can tune it. So they're relatively easy to tune. Some vehicles are more accessible than others. It just depends on what the vehicle is. Team associated vehicles, SE 6.2, not the most accessible. B6 0.1, not the most accessible. It depends. Some other vehicles are. Now, Traxxas, on many of their two-wheel drive vehicles, like the Traxxas Slash, what they use is they have the output and input gear. They're somewhat cylindrical. Now, they're not this long. They're actually shallower. But they have these 4 planetary gears around the outputs, these output shafts. And what these planetary gears do is these would be inside of a housing, so the teeth would be here for the differential. So on this side view, they would be going along this way, just straight lines up and down. And 2 of the gears, the 2 opposite gears, are in contact with one of the shafts. So this gear here that goes to one of the output shafts. So say the bottom is connected to these 2 blue, and the top one's connected to these 2 gears, and then these 2 gears are in contact with each other, and all of these are just cylindrical, straight cut gears. That's another type of differential. This is a type of differential you may want to consider red grease for instead of black grease. Red grease is just a better grease for this application. Now, if I cut out something to make it simpler, so this is what you have. One gear to this one, another gear to that one, and then the other one would be in contact with this, the other one here with this one. Now, the function is still very similar. They do the same thing. It's just a difference in design. But let's focus on fluid. Now, fluid, one of the things that happens with fluid is fluid actually creates a resistance. So as the fluid travels here between the gears have to push that fluid through. And the faster those gears start moving in opposite directions because of differential effect, the more resistance that fluid is going to create, and it's going to start creating sort of a limited slip effect in the vehicle. Now, I will show some videos to show you what I mean by that. But let's just say now your car is tracking. What's going to happen is as this wheel hits this bump and starts to unload, it will create more resistance, which means it's going to give this one more traction than you would get, for example, from a ball diff. And then as soon as it hits this other bump, now it's the opposite. This one's going to try to unload. As soon as it starts spinning faster to unload, it'll create more resistance because of it trying to push that differential fluid between the teeth of the gear. This one's going to have more traction. So what actually ends up happening is the vehicle is going to start to swerve a little. So you're going to see the rear end of the vehicle getting a little loose, kind of jumping and skipping. So if you have a surface that's really loose or bumpy, because of that limited slip effect from the fluid, it just has to do with fluid dynamics. The faster you try accelerating it, the more resistance it's going to start building. It's going to start pushing your car one side or the other, similar to the explanation that I gave with the ball diff. So this is where they differ. If this is loose dirt or bumpy surface, this wheel is going to start to unload. Now a ball diff will unload consistently, and it'll track and it'll be fine. It'll just go. A fluid diff, one of these with gears, this one will unload, but the more it unloads, it's going to apply more resistance inside of the differential, so this one's going to get more traction, which could make this a little squirrelier, for example, or make it swerve about the turn, and could potentially make you spin out. That's why many people will say a ball diff feels more planted on loose or bumpy surfaces versus a gear diff feels better on smoother, higher traction surfaces. It has to do for this reason. Now, loose dirt, things like that, again, ball diff is probably a better choice. Once you start going, this is a two-wheel drive vehicle. Now, on, say, smooth, high traction surfaces, a fluid-filled differential is going to be better. And the reason why is the following. Let's pretend this is a perfectly flat surface, and say it's carpet and you're running pins. If you're running a ball differential, as soon as you start taking this turn, this one's going to unload and keep unloading about the turn, and you're going to lose a lot of speed. And then once the body sort of settles, it's going to want to all of a sudden take off, and then the other one's just going to unload really fast, and you're going to lose a lot of speed. So really, it's just the straight bits where you're going to get quite a bit of speed. As soon as you're turning, that inside tire is going to want to unload in a constant rate. Versus a fluid-filled differential, again, imagine this is a smooth carpet surface and you're running pins. This one's going to want to unload, but then it's going to create resistance, which is going to push this wheel, or well, not push it, but it's going to make it turn. So this wheel is going to keep tracking. Because it's carpet, you're probably going to have enough traction on the front wheels to keep tracking the correct direction. This one is more than likely not going to spin out because of that higher traction surface, as it would. So this, you would be able to carry more speed throughout all of the turns with a fluid-filled differential for that reason. Because the more that inside wheel spins, the more resistance will be created in the differential at those higher speeds, which means it's going to give the tire with more traction more power. And that's the limited slip effect that something like this causes. Now, I do have another video with my team associated SC 6.2 where I ran the vehicle. Everything was exactly the same except for the differentials. I just swapped them. So go ahead and watch that video. That's the video where I'm talking about how to build a differential for that particular vehicle. Well, any of those team associated vehicles, B61, B62, B63. So I do go over that. But something else too that I'm going to show you is one of the differences that you can see on a vehicle. If you can get your hands on the two vehicles, one of the things that you're going to notice when you spin one of the tires on a ball diff is when you spin one of the tires, the other one's going to rotate the opposite direction. And if you spin it fast, the other one's going to spin the opposite direction as well, just faster than before. And if you spin it faster, the other one's still going to spin the opposite direction. One of the things that you're going to notice with the oil-filled or fluid-filled differentials is when you spin one side slowly, the other side's going to spin in the opposite direction. But if you spin it fast enough, you just accelerate fast enough, you're going to see, depending on the fluid that you're running, that if you spin one tire forward, the other tire may want to spin forward or may spin backwards but a little slower, or it may sort of cog a bit, or it may just spin forward with the other one. And that's because of that differential, that limited slip effect on the differential, because of the added resistance from the fluid trying to move faster between the gears. Now, let me go ahead and show you. I do have some videos. And here we go. So right now, this truck in here has the ball bearings. So if you see, I spin it slowly. They go in reverse direction. One is going forward, the other one back. I spin it quickly. The other one spins the opposite direction. So it keeps spinning in the opposite direction. Now there, completed, is the oil-filled diff. So I'm going to install it and I'll show you, and click, there we go, it's installed. So now the differential that you see there, this is the ball differential. So you see the plates, see the gear on the outside. But here we go. So now I have the fluid-filled gears. Notice slowly spins opposite direction. And when I spin it fast, notice how it wants to go the same direction. Watch, slowly reverse. And see how it sort of cogs? Because it actually spun the same direction of the wheel. So that's that limited effect, limited slip effect that I've been referring to. And that's the main difference between the two. So again, just to sum up, a ball differential is going to be one that's going to be more responsive in creating the differential effect. It is more ideal for loose surfaces as well as bumpy surfaces, because it's not going to pull the car one way or the other, because one wheel is always going to be unloading. The gear differential, fluid filled, will be less desirable in really slippery surfaces or bumpy surfaces, as the vehicle will naturally send more power compared to a ball diff to the tire with more friction, which will end up pulling the car one way or the other, as I explained. Right? If this one gets more power, this one's going to want to track straight, which is going to make the car swerve out. So you're going to oversteer. You could potentially spin out. And then you can oversteer here. So if it's very loose with gear, you'll oversteer here. And then you'll try to correct oversteer here and probably spin out on the second turn. Versus ball bearing, it would be smoother transition. Slower speeds through the turns, but smoother transition. Now on a smooth surface, again, you would lose too much speed with a ball differential because of the differential effect constantly working through here. Versus a gear differential will create that limited slip, which, because of the higher traction, you would continue tracking, so you would carry more speed and accelerate more through corners. So I hope this video was helpful as far as figuring out what the differences are between the application for a ball differential and a fluid-filled gear differential. And I hope for all of you that are starting racing or maybe picked up a vehicle and wondering what modifications to do, say you picked up one of those associated vehicles that I've mentioned, you can decide which differential is best for you before you spend the money. Quick little note, my SE 6.2, I've been running on carpet. I went to a fluid-filled gear differential, and it did make a difference in one of my tests. Again, watch that video about the build of the differential. It was about almost a second and a half per lap difference, which is a huge difference. That's the difference between lapping or getting lapped. Thank you very much for watching. Please comment, like, subscribe, and I'll catch you on the next one. Until later, be good.
What? Oh, my hair! My tongue! My rod!